This is 39 in Unit 60 of our textbook, where we're asked to basically determine the number of cubic centimeters of material needed for this cast plate if we know that the thickness of that cast plate is equivalent to 3.2 centimeters. So clearly we have an odd-shaped figure here, and we need to find the area of that figure. And to do so, we're going to need to break it into parts whose area we can find, like triangles, rectangles, that sort of thing, and then add all of those areas together. So you can see how I've decided to divide it up. I've got a really skinny rectangle on the far right, a wider rectangle just to the left of it, another rectangle to the left of it, and then on the far left I have a triangle. So I'll start from right to left. My rectangle area, of course, is length times width. So this little tiny skinny figure here is going to have an area equal to 6.1 times 40.8. And that is 248.88. And of course area is cubic units, so that would be square units, so that would be square centimeters. My next rectangle I can see has a width of 4.75 centimeters and a height or length of 40.8 minus that little piece on top, which is 4.75 centimeters. So when I take 40.8 minus 4.75, I get that height of that rectangle or length of that rectangle to be 36.05. So I'll multiply that by the width of the rectangle. Well, I've got to figure that out as well. And to do so, I've got to consider that the following. The entire length of that figure is going to be the sum of the 34.86 centimeters and 120.82 centimeters, which is going to give me 155.68 centimeters. And now I have to take away this piece here of 83.6 centimeters, as well as the little skinny piece on the far right of 6.1 centimeters. And that will give me the length of this rectangle, which would be 65.98. So basically I'm going to need to take that 65.98 centimeters and multiply it by the height of the rectangle, which I got previously, which was 36.05. And I'll have the area of that rectangle. And that comes out to be 2,378.579 square centimeters. So 2 down, 2 to go. So now I'll move to this rectangle here. That rectangle is going to have a length, horizontal length, of 83.6 minus the 34.86. So that'll be 48.74 here. And the height is, of course, the 40.8. So the area of that rectangle is going to be 1,988.592 square centimeters. And finally, our triangle. Our triangle has a base of 34.86 and a height of 40.80. And we have to cut that in half. So our triangle has an area of 711.144 square centimeters. So now our total area will be the sum of all of those 4 areas that we just computed. And when I add those 4 areas together, I get a total area of 5,327.195 centimeters. So finally, to find the volume, we're going to need to multiply by the height, which is the thickness of this plate, and that we were told is 3.2. So when we multiply the area of our base by 3.2 and round our answer to the nearest thousandth cubic meter, okay, this will be cubic centimeters, I'll have 17,047.024 cubic centimeters, and we've learned that to convert from cubic centimeters to cubic meters, we're going to have to multiply that by a conversion factor of 1 cubic meter over 1,000, excuse me, 1 million, multiplied by a conversion factor of 1 cubic meter over 1 million cubic centimeters, which would involve division. I'll write it as 1 times 10 to the 6th. And when I do that, I get 0.017 cubic meters. And that is what they wanted, rounded to the nearest thousandth.